Good afternoon, class. Once again, we are back to class. In the last class, we talked about first order linear differential equations. For this class, we talk about Bernoulli's equation. Now, um, okay, now gonna give a definition for Bernoulli's equation. Okay, you can see clearly that the equation exists in the form dy dx plus p of x times y is equal to q of x times y to the power of n, where p of x and q of x are continuous function of x, and also n is a real number. Now, if you observe carefully, you will see that in the previous class, we said that this form, that dy over the x plus p of x times y equal to q of x. This is the linear form, first order linear differential form. For now, Bernoulli's equation is talking about just having the kind of your y variable, your dependent variable, to a certain power. Okay, let's just continue. Now you've seen this. Now this equation like this is a typical example of the general form of what Bernoulli's equation. Now let's continue. Okay, now I'm gonna give you examples of equations like this. Okay, let's just shift this to the end. Okay. Now let's take example. Let's say example one. Example one. Now look at this. Let's say that y prime plus 2x y is equal to exponential x y to the power of 5. This is a pure example of Bernoulli's equation. Let's say that example 2, let's say dy over the x is equal to let's say dy over the x plus y over x is equal to, let's say, y squared sine x. Bernoulli's equation. Is it? Now this is your q of x, this is your q of x, and this y to the power of 5 here is the variable attached to what the Bernoulli's equation. Here I have it about y squared. Now I'm gonna teach you how to solve a Bernoulli's equation in just 3 steps to solve Bernoulli's equation. Okay, let's just play the board while I show you how to solve this equation in just 3 steps. Now watch this. Now we are gonna, the topic now is just Bernoulli's equation. Okay, how to solve Bernoulli's equation. Now we have 3 steps. 3 steps. Okay, the first step is to convert to linear form. Convert to what? Linear form. So the question now is, how can we convert to linear form? The way we convert to linear form is just like this. It's very simple. I know we have the equation to be this. We have the equation to be dy. You can see over there. You're seeing it there. So dy over the x plus p of xy equal to q of x. So the first thing to do, if you are trying, if you're trying to make the Bernoulli equation become a linear equation, so what will you do? You just divide both sides. Watch. You see, you divide both sides by what? by y to the power of what? N. Now, if you do that, I think you have if you divide both sides, you're gonna have this. You have y to the power of negative n dy dx plus y to the power of 1 minus n p of x equal to p of x. Now, at this point, the next thing you do as to enable you to come out the linear form is to say let z, okay, let me show you at once. Okay, okay, now you're gonna say let z equal to y to the power of 1 minus n, and then you evaluate dy dx. Once you get the y over the x, it's finished. You know, you have your z to be y to the power of 1 minus n. Yes. So to get your dy dx, dy over the x, you know, from chain rule, dy over the x is just the z dy multiplied by I think is dy dx, so that these two can remove each other. Have sorry, there is the z dy, the z dx. So the z dx is this, okay? The z dx is this. So I think they are both equal. Observe carefully, see they are equal. Now you're gonna get this first. From this, you can now find your dy dx. So the z dx, the z from this equation now, the z dx will be the z dy I think is 1 minus n multiplied by y. This multiplied y, I remove 1 and I have minus n. Then my dy over x. So with this now, I think I can just make my dy over the x the subject. If I make dy over the x the subject, I think I'm gonna have it to be let me show you at once. Oh, sorry. Menu. Okay, I'm gonna have it to be this. See, it will become that the y over the x is equal to y to the power of n over 1 minus n times the z to x. Okay, now since you've gotten this, the next thing to do is to put the, okay, let me show you the next thing to do. Let's clean up this. The next thing you do is to put that your value of the y dx and also the value of v equal to y to the power of 1 minus n into the part A. Into the part A, where we said that if you divide both sides with y to the power of n, that first part, that thing you obtain, you plug your dy dx into there and plug your value for v equal to y to the power of 1 minus n into there. I think you're gonna have it to be this. Yes. This is what you're gonna have. So you have it to become the v dx plus 1 minus n times v p of x equal to 1 minus n times q of x. Okay, you can see clearly now. Let's take the number 2 step. Number 2 step is just that you have to solve the linear first order differential equation. You know, in the previous class we've talked about linear first order differential equation. So now you're gonna solve this yourself. If you are confused, you can go back to the previous class on linear differential equation. So I think after solving that equation, you have an answer now in terms of z, not y, because the question was asked in terms of y. So you just have to, so you can just write it down anyway. So that's the next thing there. Just solve the linear differential equation. Now the number 3 thing there is okay. Number 3 there is transform in terms of y. You know, originally the question was asked in terms of y. So are you having something in terms of z? So when you transform, I think we make use of the value of y of z equal to y make use of z equal to y to the power of 1 minus n. Let me just